Hello, in this video let's discuss fourth question of today's contest. You are given an integer array nums of length n where each element is a non-negative integer. Select two subsequences of nums. They may be empty and they are allowed to overlap, each preserving the original order of elements. So x be bitwise XOR of all the elements in the first subsequence, and then y be the bitwise XOR of all the elements in the second subsequence. Return the maximum value of x XOR y. A subsequence is an array that can be derived from the given array by deleting some or no elements without changing the order of the remaining elements. The XOR of empty subsequence is 0. For example, if the vector is 1, 2, 3, we can simply select 2 and 2, 3, and we can XOR all those to get the value of 3, which is highest. So we have to return 3. In this way, we have to find the maximum answer. The constraints are n is up to 185 and the values are up to 199. So the question is simply saying that you are given an array with length 185 with length less than or equal to 185. We can select any two subsequences. They may be empty or they may be overlapping, and we have to return the maximum XOR of two subsequences like that. So let's assume that the first subsequence which we are selecting is ABCD and IJK. So ABCD in the first one, EFGH in the second one, and then IJK in the both. So they may be overlapping. So let's assume these three are the indices where both subsequences have the indices in common. So ABCD are the indices in the array only when they are a part of first subsequence. EFGH only in the part of second subsequence, and then IJK in both the subsequences. So if this is the case, then what is the XOR of all the elements that we selected, which is subsequence 1, XOR subsequence 2? It will be simply XOR, B XOR, C XOR, D XOR all of these. And there is no contribution with respect to IJK. Why? Because these are included in the both subsequences. So XOR of these both is simply 0. So only the elements which are only in first subsequence or only in second subsequence are important. The indices where they are in the both in common are useless because they simply contribute 0 to the answer. So from this what we got? So it is simply all of XOR of all these, right? There will be no IJ in K. So from this what we can understand? We can understand that it is simply the subsequence of other subsequence. It is simply the XOR of other subsequence, because these 4 are in the first and these 4 are in the second. So why not we select a single subsequence of combining all these? So we can simply boil down the given question to maximum subsequence XOR. Like we can take any subsequence and we have to simply return the maximum XOR of any subsequence in the given array. So the given one can be boiled down to this. So now how can you do? So greedy will not work. Why? Let's say we have these two, 1001 and 1011, and let's say we have other number also 0010. So what is the first thing? So why not we just think that take the highest number from these both to get the subsequence from this, to get the XOR from this. Let's say we select this, which is the highest one. So if we select this, then what is the XOR of these both? It is 1001. So because 1001, because 1 is in common, so 101 is 0, 0 XOR 0 is 0, and other is both are 1. So it is 1001. And what if we select the less one among these both? Then what will be the XOR? It will be 1011. So from this it is very clear that we cannot make greedy, because selecting the less one is giving the highest XOR. So now what we can think? So now we got that finding the answer is difficult because no greedy one. So how can we determine which subsequence to select to get the maximum one? So now what we can think? We can think what is the simplest configuration that we can get so that the answer finding is easy. So what is the simplest one we can think of? So what if we have something like this? 1000 0100 0010 0001. So if this is something like this, then what will be answer? It is simply XOR of all elements, because there are no two numbers which have two set bits at a single index. So what I'm saying, for example, let's say we have 1010 and 0110, and there are many elements. So why is the problem difficult? Why not the answer is simply XOR of all elements? For example, if the operation is sum, and if the all elements are positive, we'll simply add all those, because selecting more numbers will obviously increase the answer, because the numbers are positive. But why we are not sure that XORing all the elements will give the maximum sequence? Because let's say we have 1101 and let's say we have 1111. So what if we select both of these? So the main problem here is it is modulo 2. So let's say we have 11. If we select this both, the value will become 0. But what if we select only one? If we select only one, then the answer will be higher. But here we are selecting both because we assume that we are selecting the whole subsequence. But here what is the case? If we select these both, then the subsequence XOR will be 0010, which is far less than any of these. So from this we got that the main difficulty here is not selecting the whole array, but selecting only few elements, because selecting more numbers with a single bit highest as 1, the XOR will become 0, which is simply useless. So now what we can think, the main thing now is what is the simplest configuration that we can find the answer very easily. So when the numbers will be like this, the answer is very simple to find, because it is simply like no two numbers have bitwise and as 1, so that we can select all the numbers in the given array. So this is the simplest that we can think, and the answer will be simply XOR of all elements in the given array. But obviously this is not the case. So now how can we think of? And also, let's say we have this one. So let's say we have something kind of this one. Then what is the thing? So this is exactly this one. But here what is the thing we assumed? Because this is simplest one ever possible. So we thought that there is only one number with that one. So we can simply XOR. So this is valid for numbers like this also. Let's say we have 10000001. So even now this is the case. We can XOR all the numbers which is 1001, which is the highest amount possible. Because by taking no more than 2, no bit is setting to 0. So this is what we thought for now. But let's slightly increase the complexity. So now let's say the first bit is the only number which have highest bit as set. So 11001 is the only number where fourth bit is set. So now can we think of anything? So now a single bit is set in more than one position. But the main thing we assume now is the first number, the number with the highest set bit is only 1. So now can we think of anything? Because this is slightly greater than this one. We assumed something, but this is far better than before because we are able to cover more number of arrays here. So now what can we think of? So this is the only number with the highest one, right? So if this is the only one, will we ever miss this? Obviously no, because this is the only number with the highest bit set. So why anyone will lose this? So surely 11001 will be in our final answer. So this is for sure. Even if we take any other element, this will not be reduced. We will only consider the numbers which will increase our answer. So indirectly, which will increase this. So we got this in subsequence. And then coming to second one. So we have 01101, 01100. So we will consider this or we will not consider. So what if we consider this? So if we consider this, what will be the new XOR? It will be 10101. And what if we don't consider this? The number will be 1, the XOR will be 11001. So which is better? So obviously this is better. Why this is better? Because the highest bit in this, after the highest bit, like the highest bit after this is set here itself in the bit 3, but here it is set in the second bit, which is far less than this one. So from this what we got? So now also it is simple, right? So we have a single number because we assumed that the number which has the highest bit set is only 1. So we'll surely consider in the final subsequence. But coming to next bit, we have the final one. So we will not select the number if the bit is already set in the answer till now we got, right? So let's say the only answer till now is 11001. So now we got to the next element, which is 01100. Why we will not consider this in the XOR? We will not consider this because the highest number, the highest set bit here is 3. But the set bit, the bit 3 in the number is already set here. So if we take XOR of this also, the third bit will become 0, which is very bad. So now we are able to get something, right? So we have a number, and as we are traversing the numbers, we will check the highest bit of that number. So if that number is already set in this, there will be no use of this number because it's already set. If we assume this again, then the bit will become 0, which we are reducing than this. So if the numbers are like this, if the number with the highest bit set is only 1, then our answer is straightforward. We will select the first one, and then based on the traversing, we will find the highest bit of that number. If that is already set in the number we are having, then we will not consider this because it will surely reduce our answer. If that is not, then we'll simply XOR. So let's say we have the number 11001 for now, and the next number we have is 0 0 1 1 1. So if we have this, so is there a use of using this? So if we use that, then what will be answer? It will be 1 1 1 1 0. So is this better than 1 1 0 0 1? It is obviously better. Why? Because we are having a set bit here than this. So this is surely better. But can these both be common? So now what we thought, we are thinking about the highest bit. So the highest bit of this is this, but this bit is unset in this also. That's why we are considering this both. But this is also set, but this is also set. So we will not consider? No. Because in the binary numbers, the highest bit will determine the higher value. For example, let's say we have 1 0 0 1, and let's say we have 0 1 1, and let's say we have 1 0 0. In these both, which is better? Obviously only this one. Even though it have many other set bits, but the only number which is high is this one, because we have highest bit set here. So from this we got the conclusion that we will blindly assume, like we can assume that if the only number with the highest set bit is 1, then we can simply find the answer by traversing and finding set bits. But that is not the case. So now how can we think of? So why this configuration is easy? This is easy because we assume that the highest number is always 1. The highest number with that set bit is always 1. But that is not the case. So now what? So let's take a big example. So in this big example, then what can we think of? There are many numbers with set 1. There are many numbers with this bit, this bit, this bit set. So now let's take this one. And now let's think what can we do for now. So let's say we have three numbers. We have three numbers with highest bit set. 1 1 0 0 1, 1 0 0 1 1, 1 0 0 1 0. So in this way, which we will consider, we will select the highest one. So let's say we have these one, we have all these. So let's start with the highest one. So what if we select the highest one and we have two other numbers also with this z bit? So can we do any operation between among these three so that only one number will have the bit as set and other will have both as 0? So we have three numbers with highest set bit. What if we try to make these three into three different numbers so that only one has one here and other have both zeros? So if that is the case, then it is simply boiling down to the before one. So now what can we think of? It is simply like XOR. So because we have 1 and 1 and we have to make this 1 0. So what is the operation we can think of? It is simply XOR. So what if we XOR this number with this? So this will remain same and this number will become XOR with this number. So this will be the new number. So it is simply called Gaussian elimination and this is useful in problems like this. Why? Because we can simply make the choice unique based on the bit we are selecting. So this is what we exactly want. Because if we have only one number with highest bit set, then we can find the answer. So this is simply like unique. This is like unique factor for every bit. So this is why we are assuming that we have many numbers and which operation can make our answer boil down to simple one, where only one number have the highest bit and other will have 0. So in that way we thought of XORing the numbers. So now what we thought of? So let's say we are thinking about thinking about highest bit, which is 31. So now we have many numbers with bit 31 set. So we can think of any way. We can make this and we can make these both 0. We can make these both 0 and we can make this one. Any way is possible. So take some examples and try to get why these are same. So for now, let's assume that we are taking this highest number. So we will take the highest number and then we will XOR the numbers with highest bit set, so that we are ultimately boiling down the whole numbers into the previous set where only one number has the highest bit as set. So now we got the highest number and we will try to XOR these both with the numbers where the highest bit is set. So now these both numbers will be different and then we will. So now what we got? Now we got the answer for 31st. So now there is only one number with 31st bit as set. So and then we can try to follow on the same procedure for other bits also. So now we will start traversing the numbers with 30 bit. But we should not consider the one which is already considered for 31, because there should be only one number. So there may be any number of bits that can be set here. So the next number will be only selected if the next bit which is not set in the first number is greater. So let's say we have 1 1 0 0 1, and let's say we have other number also 0 0 1 0 1, and let's say we have 0 1 1 0 1. So this is the highest one. So we selected one. And coming to this both, which we will consider? We will consider only this one. Why? Because one is already set here. So we should not think about this number. Because we already got the highest number with respect to this bit. We also got with respect to this bit also. So the only thing left is this bit. So how can you get this bit set? By taking the number which is set here. So from this what we got? So we should not reconsider the same numbers for 30. So why? Let's say we started traversing with 31st bit. So we got this number as the highest one. So for 30, we should not get this number because it's already for set bit 31. So we should not consider this. So then what? So from this we thought that instead of traversing bitwise, it is better to traverse number wise. Why? So for a number, it will be only once for a bit. So let's say we have 11001. So for 11001, this number will be stored in which bit? It will be stored in 0 1 to 4th bit, not 0th or 3rd bit. Why? Because it is significant only for highest number. So from this what we got, if we travel bitwise, then the same number can be considered twice. But what if we try to traverse the number wise? Then only we can try to, then we can only get for the first bit, and then we can break the loop so that any other bits will not be set for that number. So we got that we have to traverse number wise instead of bitwise. So what we want simply like bit of I is the number in the final vector such that it is highest with ith bit set, which we exactly discussed. So if we got this, then it is very simple. It is exactly like the one which we discussed before. So now we got it right. So let's take an example. Let's say these four are the numbers, and let's start with 31st bit. So is there any number with 31st bit set? So we'll start from number wise, right? So we'll start from this number. So we'll start from 11001. And is 31st bit set? No. So continue. Is 30th bit set? No. Continue. Is 24th bit set? Continue. 0 1 2. So is the 4th bit set? Yes. So this is it. So now bit of 4 should be this number because this is the highest number we got. So bit of 4 is 25. So after making this 25, so bit of 4 is 25. And then should we continue to third bit? No, because single number can only contribute to 1. So hope you got this. Why we got this? Let's say we have 11001. So we got these both numbers set. So initially when we are starting, this will be the answer itself because this is the only number with highest beta set. So this is the only number with highest beta set. So we'll consider this in the answer. So now next what we will consider? We will consider the only number with second beta set. So we'll consider some number like this. Only some number like this. These both should be 0. These should be 1. And what is this? It is simply bit of 2. Why bit of 2? Because this is the number we exactly want. Now we want the number with highest number with bit as set as 2. Like the number where second bit is set. So this is what exactly want. Because these two are already here. The fourth, third bits are already here. Now we are searching for only 2. So from this also we got that if we got a highest number, so simply break the loop. Because we will anyway consider this in the number. So why thinking about these all bits? Right? Because we already discussed that, right? So we have a given number. And then we will traverse the bits and we will only consider when there is no bit set here. So we discussed here, right, in the first of the few slides. So we got 11001. So we will not consider the number where this bit is 1. Why? Because it's already set. We will consider only the number where this bit is 1. So which we want, because we already discussed that there will be only one number with that bit set. So which will be simply 001. 001 dash dash. These are don't care. So this is the number we want. So which is exactly bit of 2. So when we are traversing through a given number, when we get a bit as set, we'll simply break. Hope you got this. And then we will continue the whole loop for all the numbers. And then after ultimately traversing, we will get the bit array where bit of 4 is the highest number with that bit set. And bit of 2 will be the highest number with that bit set. So we also should know that there must be something like initially 0. So that there is no number with that bit set. So if that is the case, then we don't have that value. Then simply continue. And now let's check the code. So we already discussed it. So we'll traverse from highest bit to least one. And then we'll consider this in the answer. And coming to next one. So coming to next one is the highest bit in this is already set. This is set. So simply don't continue. So just don't use this in the final loop. Final answer. So coming to this 0 0 1 1 0, the highest bit here is 1. So is 1 set here? No. So we'll add this. So XOR of these both. So this will be this. And coming to next one. So this is the highest bit. Is this already set? Yes. So don't consider. So this is the final answer. So let's check the code. We are simply using bit of 32 is equal to 0, which indicates that all are initially 0. And then sort this and then reverse this so that we can get the highest number. So even without this will work. Because ultimately it depends only on the bit, only uniquely on the bit set. So we can consider any subsequence. So let's say we have 3 numbers with highest bit set. So answer will work even if we make these both as 0, or these both as 0, these one, or these both as 0. Because only bit is dependent. The bit will be 1 even if we select these 3, even if we select these 3, even if we select these 3. So the answer is dependent only on the bit set, but not on the which numbers. But for simplicity, I just sorted and reversed. And then start from the loop. And then simply first we are finding bit of I vector. So we are starting with the highest bit. And if this bit is not set in the given number, so if it is not set, then simply continue the bit. And then, so if we came here, so when we came here, what does that mean? It means that the bit is set. So if that bit is set, what we'll do? We should find whether this is already set by before number or not. So if this is already set, let's say we have 1 1 0 0 1 0 0 1. So let's say we have these two numbers. So initially coming for this number, because we start from highest number, so we start from this. So when we start from this, we made bit of 3 as the 0 1 2 3 as 12. So bit 3 as 12 and we broke the loop. And now we are coming to this. So even here the third bit is 1. So we should make bit 3 as this number? No, because bit 3 is already considered. So if the bit 3 is considered, then what should be done with respect to this? So this should be XORed with respect to above number. Why? Because we discussed that, right? We are selecting this number and we'll make all other numbers with this highest set bit XOR of that value. So we have 1100 and we have 1001. So what we are going to do? So this is already set. So this is already set. That's why bit of 3 is 12, which is not 0. So then when we are at this number, what we'll do? We will update this number as 0101, which is simply XOR of these both. So by doing XOR only, we reach the simplest vector. So when we are coming back also, we have to make that sure. So we are simply XORing of this, which we discussed exactly before. So simply, if that is not set, this means that this is the first number. So simply make it X and XOR and simply break. This means that with respect to this number, we broke the loop. We will continue to the next number. And then if this is already set, so if this is already set, then what we should do? We should simply XOR with that bit value, because that is where we exactly storing the bit value 12. So we should XOR with 12. So to get the new number. So in this way, we are able to get a single number with highest beta set, so that we are able to get the answer. So after this loop, we are able to get that simplest vector, and then initial result is 0 because there is no subsequence, and then start again from 31st bit. So by starting, if this is not set, so let's say we have no number with 31st beta set, so then what? Then simply 0. So if this bit is not set, or so then when we will consider this, so when we will consider a number in the given answer, we will consider only this if the highest bit in this is not set in the given vector, right? So we are at first bit, we are at 31st bit. So we will consider this only if the result will not have 31st beta set. If the result is already having the 31st beta set, then why will make again 31st beta 0? So we'll not XOR this, right? If this is 1, then don't break this one. Simply continue. So if the present bit we are at is already set, then don't continue. Or if there is no number with the present bit as set, don't continue. So then simply continue. And then if we came here, this means that we are able to take this in the final answer. So simply result bit of I and simply return the answer. If you have any notes, comment below. See you in the next video.